derivatives of exponential and logarithmic functions. What's the base of a natural exponential function?
Hi, Joyce. E.
Definition of e, one way of seeing it, y equals e to the x if and only if x equals ln of y. You're like, their definitions are based on each other. Yeah, kind of. However, there is a much more technical definition down below, but I want you to put this in big old parentheses. We're not making this an endeavor. It's not something to memorize. It's not even something we're going to use much. At least not right now. But it is technically another way of defining e, which is interesting.
Wasn't it like an infinite limit of 1 plus 1 over x to the e of 1 over x to the 1 over x? I wrote it down.
You mean this thing on the bottom? It's an integral. Oh, you're talking about the limit as, you're talking about the special limit. That's different.
Yeah, 1 plus x to the 1 over x.
But that is another way of describing this. But that's different than this one. How are we solving? ln? That's what I would use too. Because ln of anything, right, we can bring it down, and then ln of e is just 1. So we can solve for x by, this is just quick review of logarithmic exponentially stuff, right? So logarithms undo everything exponential if we need them to. We're going to use that a little bit today to try to remember some of these properties that some of you still don't have super well done. Hopefully that was last year's people, not this year.
I think I was fine.
Ready, set, and?
Oh.
I'm just kidding. So, derivative rule.
Yay.
d dx of e to the u. Well, how do we do that? Careful.
Which equal, I guess you get that code.
Isn't it still e to the t prime?
Yeah.
Technically, but where does it come from?
Or we like
Chain? Oh, it comes from the derivative of e to the x is e to the x. Maybe?
Maybe. Maybe we could see it as not e, that's 1. You could also rewrite it. And then we could derive it. Oh, stink-a-dink though. What derivative rule do we need now?
1 over x. 1 over y. That's what
y dy.
Oh,
no.
Yeah, 1 over y dy dx.
no.
Oh,
Wait, is the dy dx in the bottom?
The derivative of u would be u prime, right?
Yeah.
And
So that's a quick little recap of.
Wait. Is the 1 over is the dy dx on the bottom of the 1?
What?
Like, is that on the denominator?
You can't combine.
No.
it's 1 over y.
Times u prime.
Thank you.
Times u prime. Which is dy dx, and so we can go ahead and say dy dx. Hence, the derivative of e to the u is y times u prime, and y was just e to the u times u prime. Nothing changes.
Yay, close enough.
Nothing changes,
It's so cool.
which is why we like e to the u. We could technically use the definition of derivative inverse. We could do it that way as well, but either way it works. So the nice thing is, the easy ones down below, easy cheesy. We should never miss them, right?
Right.
The common mistakes other kids make, we won't.
Right.
dy dx is equal to
E to the u times u prime, which is 2. Oh.
Yeah. 2e to the 2x minus 1. That one's not too bad, hopefully, right? But what's going on with letter B?
Gotta do a quotient. No,
Don't have to do quotient rule. What's another way of looking at u?
make negative 3 and then x to the negative 1.
I mean, with your eyes.
That's what we're doing the whole time. Then we can bring down the negative 1 and have 3 over x squared, yeah? And for sake of simplicity, we just make it 3 over. Hey, wait a minute. Is this the same thing?
Oh,
Yep.
Yes.
Why? Because e is to a negative power. You could always put that below.
That was
Right? Because the negative power of e would flip it down. Exponent rules.
Times 3.
So this numerator denominator. this could transform into 1 over e to the 3 over x. 3 times 1 e to the times x squared. Good?
Yeah.
Woo! But how does it get more exciting?
Oh no.
Oh no, what if it's not an e? What if it's a number? Like 3.
Oh yeah.
Oh, change your base formula?
No.
No. I mean, you could make it. I mean, what Gerardo was saying is that you could make this log base 3 of 1 over 81 equals x. You could do that.
Can we do
But then on
So
the
then you
other-
have to change your base. That's disgusting. What's another way?
Don't you
Five
do
bases.
81 to whatever power, or 3
You
to
could
whatever
see
power?
if 81 can become a 3 to the, which is possible, 3 to the 4th. How do I know that? Because 81 is 9 times 9, and each of the 9s are 3 squared, right?
Genius.
They can't be the negative.
Which are we? Do you float in water?
Do you float in
Do
water?
you want us to write the properties of
Do you weigh as much as a
As long as you know them, we're good. Yeah,
They're my honors pre-cal notes, right?
they're good ones to review.
I'm gonna write them just in case.
Yeah, me too.
And letter B, there is the way to go back and forth from exponential to logarithmic and vice versa, right? There is the way to go back and forth. We can also undo, like this one over here, we could have done log 3 both sides. This one we can do 2 to the power of both sides, if you like that way better. It's a little bit simpler to remember. Two to the 4th, 2 times 2 is 4, 4 times 4 is 16, yeah?
Pre-cal kids ask the question what they're going to use, what they're learning in calc.
Yeah, but most of the ones that are asking that are not thinking about that.
I think this was the homework that I accidentally did.
Oh, this one was? Because you're like, I recognize this. Ah. So sad. You saved it though, right? You didn't like totally trash it?
Well, because I did the wrong numbers for it too. I did the numbers for 4.2 on this one.
So it was like totally mixed up, not only the wrong page, but also. I thought you had done the numbers of on, that's why I answered the way I did. It was backwards.
Steve, how did you know that 81 is 3/4?
I ended up, well, A, I kind of have it memorized, and then B, I also think factor and trig. So I have 4 3s.
Okay.
Couple more seconds to remember logarithm stuff, exponentially stuff. Why on earth are we reviewing pre-cal algebra 2, algebra 1? Well, I don't know, whatever.
Oh.
Because, oh, sorry. 2 more seconds.
Okay, got it.
I already got it.
Mhm.
Because we're going to find our derivatives using those properties. And derivatives of what? Derivatives of
Logarithm.
those are the interesting ones. We already have, before we get to these funny ones with funny bases, whether it's a funny base logarithm or a funny base exponential, we still have d dx over here of ln of x, which we already said was 1 over x. And over here we have d dx of e to the x. How do we do it once the base changes?
When you say simplify first, means simplify the first, or the first thing you do is simplify?
First thing you do is simplify if you don't have the properties nice or the derivatives nicely memorized. Does anybody have the derivative nicely memorized?
Yes.
Okay.
1 over ln of b times log, no, times u prime, right? Or ln, no?
Isn't it 1 over b ln of x? X ln of b.
Oh, that's ln.
And it would be u ln of b times u prime if the u is applicable. But how do we know for sure? And for those of you listening, this is from AP Kids from last year. It took 3 tries. So, how can we know for sure? 2 ways. One way is to do b to the power of both sides and know that rule. That's one way. You could do b to the power of both sides and know that rule. But Technically, we don't know that rule yet, so hold on. What's another way of doing it? Saying any logarithm can be written in terms of natural log.
Ooh.
Change a base formula,
Product rule?
right? Nope, not product rule,
Don't say quotient rule.
not quotient rule.
Thank God.
Constant multiple rule.
Oh, there's no
Yes!
constant.
Because we can just make this, rewrite 1 over ln of b times ln of x. True? And we can say it's dy dx is just equal to, and we write the x first because that way ln of b is second and it's not as confusing. But, here we go. Sure? So what do we do over here?
Wait, derivative of a constant. ln of b is a constant, right?
B is a constant, u is not. U is a variable expression, like b to the f of x.
No, last one, wouldn't it be 1 over b, wouldn't that be 0? Oh, it's on the outside of the derivative.
If we did quotient rule, you would have a 0 in there somewhere, but no, we're not doing quotient rule. Can't do e to the power of both sides. Can't make b into e, but what can we do? Nice.
You were kidding when you said ln was more useful.
And e. Not kidding at all. So I end up with ln of y is equal to u times ln of b. What am I going to do? Implicit. Differentiation d dx at both sides, and I end up with derivative of ln of y. Y is a variable, 1 over y.
dy dx.
dy dx. On the other side,
U prime times ln of b. No, yeah.
yeah, ln of b is just a constant, so I can say u prime times ln of b
Multiply the y over.
dy dx is equal to y times u prime times ln of b, which ends up being, who is y? Look back at the beginning. Hey, just like b, or e to the x, staying e to the x, b to the u stays b to the u, but what extra constant do I have?
ln of b.
And then we just put u prime at the end because that's where we always go. And why is there a u prime? Because I didn't have him be an x, I had him be a u. True?
Have you finished writing? Yeah.
So, any excuses for ever forgetting these again?
Yes.
Nope. However, ultimately, would it probably be helpful to have these memorized? Yes. And some of you kind of do.
Wait.
But there's always that possibility that there's that mental breakdown. You don't need to feel stuck. Huh?
Very possible.
Very.
How do you know? How did you get b to be b to the u?
Because we have a y, and who is y to begin with? Kind of like with implicit differentiation, second derivatives dy dx, go back and plug in. What? It all ties together. So derivative b to the u is b to the u, just like derivative e to the x is e to the x, but there was that base that we had to deal with, hence the ln of b times u prime. Is there any fractional anything with b to the u? No. But log, will there be a fractional? Yes, because ln had a fraction. Just like ln, 1 over x, or I should say 1 over u, that's good, but that base I had to compensate. Times u prime. It's in your forevers. No need to rewrite it, but there is a need to possibly rememorize it. Right? So you guys, ready, set? Go! Go, 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 go.
We didn't find u prime. Square root of x over x plus 5.
My turn to have fun. Done, done, done.
I hate myself.
Split up the log. Oh yeah, I did that.
Dun, dun, dun.
ln of
Can
a.
you do that? Is that legal?
Think about it.
You say it's legal.
Oh,
No, we're 39, right?
For some reason, I was the fact of
I think you just got jumpy with the button. I don't know how they work the thing. I'm gonna be honest.
What?
I don't know how they work it. The bell system.
It's just like a buzzer, like an alarm every certain hour.
No, like, but I always hear people being like, "Oh, this person who usually does it. Oh, I guess he just messing up." I'm like,
Okay.
Why is
Obviously that's
Ellen
not
on the top?
"Thank you."
Oh, it shouldn't be on the top. I was
Yeah.
having too much fun with my tangent and not paying attention.
Do
So
we
what
have-
I could do is make it positive, and then Ellen should be on the top.
Wait, why would that make that one be on the top?
Oh no, it wouldn't be Ellen 1/10 in the bottom, which would be lame, because that would look dumb. I was trying to save it and it didn't work.
It's okay. I forget.
Can't you just leave it negative tangent of x over 11 times?
Yeah, I suppose.
Square root of x is 1 over 2x squared. 1 over 2 root of x, right?
Like that. I feel like it's square root of x.
What do you
1 over 3, right? 1 over u, that flips. True? Times on of 3 times u prime. And u prime, oh, then you have to do quotient 1.
No,
Makes
split
sense.
up the-
just split up the log?
Oh, what are you guys doing? But technically, isn't my way right? 1 over u
Yeah.
times ln of 3 times u prime?
That's a lot of work.
I
But what's
don't
the
know-
better way?
I don't know what you're doing
Split up the
actually.
log.
1 over u times ln of 3 times u prime. We're using the property. But the nicer way is if we did, it's not an ln, log base 3 of x 1/2 minus log base
There we go.
3 of x plus 5, because x to the 1/2, the 1/2 can come down, the subtraction is for the division, and we end up with 1 over 2x ln of 3 times x prime is 1 minus 1 over x plus 5 ln of 3 times x plus 5 prime, which is just 1. And I guess if they really, really wanted to, they could do something snazzy with common denominators. Yeah,
Like 1 over
pull out an ln of 3. Yeah, you could do like
1 over x plus 5.
Yeah.
Steve,
Combine
Frog.
them, kill yourself.
from B,
Couldn't
when you multiply u prime, you add it into the ln, not to the 2x or 2 to 3x.
Yeah, how did you get 11 of 8?
So the 3,
3 is just multiplied, right?
ln of b times u prime?
oh,
Oh, you can put it in the power.
Got it. That makes sense.
Yeah,
Are
goes
you sure you don't weigh as much as the duck?
because
Oh, I
multiplication
get
is
it.
commutative, and then 3 pops up.
How does that equal 8?
2 to the third.
Cubed is?
Ah. Now, how did you get ln of 2 times 3?
Times u prime. U prime.
ln of 2 times u prime.
Yeah.
Ln of 2 times u.
And u prime. Derivative of 3x is 3.
That would make it.
We're gonna get back to that. That's actually more of a future thing. Let's end with this page.
Do you know how to derive this?
This one's getting you ready for what's to come
No. I'm not going nowhere.
after derivative applications.
We have to do derivative application.
Yeah.
Just kill me now.
No, that's why we have to do it, so that it won't kill you later. So we cause you a little bit of pain. It's called football practice. Okay, so for calculus. Logarithmic differentiation. You guys just used it. Why? You brought in an ln. Actually, there already was one. There already was an ln, and you used cool ln properties. Use cool ln properties to simplify before deriving. Let me actually put properties in there. So question, why do we have to know how to do this? Because, is there a rule for how to solve the derivative that you see? For the function, the derivative of the function that you see?
Yeah.
There's no rule. Because we have a variable to a variable. It's not a b to the u, it's not a 2 to the x, it's not an x to the 2. What's the only way to do this? La, da, I'm gonna keep going. You guys get out of here. Bye. See you later. Do homework for tomorrow. 1 over y dy dx is equal to second b first, which is just ln of x times 1 plus first b second, which is x over ln of, x over 1 over x times 1 over 1.
George?
Yes, Jesus loves George. Yes,
F inverse of 3.
my water.
Right?
Miss D, you're trying to steal my water?
I am not trying to say.
Why'd you keep it in the room, huh?
I'm just gonna have to replace them all.
You give me an advice, huh?
I really like being late to classes. Okay, if prime, I found f prime. F prime will just be, f prime will just be 4 cosine of t. So 4 cosine of, so when this sine equals 3/4, when this sine equals 3/4. So it would be 4 4 cosine of sine inverse of 3/4. And this is the inverse. So you take the derivative of the original. Yeah. And then, but if so now I put that in my calculator or something?
That's why
So you're saying that if I get something that's not even circularly, I need to go resort to that?
because otherwise you can't do that. So you won't be able to fill in that value.
So I really will have to memorize my forevers. No, I'm not going to eat it. Well, it's a good thing I didn't read my forevers, memorize it.
Yeah. It is a good